Welcome to the world of Ashwa Racing, India's premier SAE racing team. We pioneer to excel in the arena of motorsport and add to it a new dimension. As a concept race car, we present the Ashwa Hybrid Electric Vehicle or HEV, Asia's first hybrid racing car. Overview. The Ashwa HEV is essentially a car where both the engine and the battery supplement each other during the motion of the vehicle. As against conventional cars, the battery plays a more active role in the vehicle propulsion. Here is an overview of the various components that make up the Ashwa HEV. These components work together in precisely engineered harmony to get optimal performance in every situation. Internal combustion engine. The main source of power in the vehicle runs on conventional fuel. High capacity battery pack stores energy in the form of electricity and supplies it to an electric motor as and when required. Recharges within the vehicle and does not need to be plugged in for recharging. Electric drive motor converts electrical energy from the battery into rotary motion to propel the vehicle forward. Generator converts the surplus mechanical energy from the engine to recharge the battery. Hybrid transaxle connects the engine, generator, drive motor and the rear wheel drive together and allows power distribution between engine, battery and the rear wheels. Power control unit, the brains behind the Ashwa HEV. It monitors the power output of the engine and battery and the energy distribution between the two. Regenerative braking system converts energy from wheel during braking into electrical energy to recharge the battery. Overview. Let us now look at the real-time performance of the vehicle. Startup and low speeds. During the initial acceleration and at low speeds, the vehicle is powered only by the electric drive motor, using energy from the battery. Besides saving fuel by keeping the engine inactive, the electric drive motor also delivers maximum torque instantly for impressive acceleration. Acceleration and overtaking. During strong acceleration and overtaking maneuvers, the drive motor that draws energy from the battery and the engine team together to power the vehicle. This combined performance gives maximum power to the drivetrain. Thanks to the hybrid transaxle and the electronically controlled continuous variable transmission, acceleration is smooth and seamless. Cruising. At higher cruising speeds, the engine does most of the work with the motor kicking in as and when necessary. This synergy is maintained by the ingenious hybrid transaxle, which transmits excess power produced by the engine, is automatically converted and utilized to recharge the battery. When the vehicle is cruising at low speed, the engine and the motor reverse roles. The motor provides power to the rear wheel drive. The engine automatically recharges the battery when the power is low. Braking. This is one of the most remarkable features of the Ashwa HEV. The moment the brakes are applied, the energy that is normally lost as heat is captured as electrical energy and is used by the power control unit to recharge the battery. For sudden stops, conventional brakes are applied, overriding the regenerative system. When the vehicle stops, the engine turns off and the drive motor stands silently, ready for action. Reverse. The power control unit automatically shuts down the engine during low speed situation like reversing. Only the electric drive motor is used to power the vehicle. The transmission for reversing is controlled by the ECVT. Hybrid transaxle. The hybrid transaxle or the planetary gear system is the heart of the Ashwa HEV. This gear system has two halves, the power split device and the reduction gear. The power split device is connected to the engine and the reduction gear is connected to the drive motor. Power split device. Sun gear connects to the generator. Planetary gears connects to the engine and connects sun gear to ring gear. Ring gear connects to the rear wheels. Reduction gear. Sun gear connects to the electric drive motor. Planetary gears connect sun gear to ring gear. Ring gear. Let us review the working of the transaxle in various situations. Startup and low speeds. The reduction gear harnesses the high RPM power output by the electric drive motor, transferring strong torque to the drive wheels and allowing the vehicle to move under electric power alone during low-speed driving conditions. The power split device automatically distributes the engine power to both the front wheels and generator as and when needed. Additionally, it allows the generator to start the engine without the need of a starter. When the vehicle reaches higher speeds, the generator momentarily stops, causing the planetary gear to rotate around the sun gear. Acceleration and overtaking. During heavy acceleration, the engine is spinning the planetary gears. Most of the engine's power goes through the ring gear to the wheels. The rest goes to the generator via the sun gear. The electric drive motor, powered by the battery, also rotates the sun gear on the reduction gear side. This, in turn, rotates the ring gear. As a result of the motor combining to spin the ring gear, the vehicle experiences an impressive surge of power. Cruising. At cruising speed, the engine supplies all of the power to the ring gear via the planetary gears. However, the speed of the ring gear is further increased due to the backward rotation of the sun gear by the generator. The sun gear rotation is harnessed by the generator to recharge the battery. Braking. When the brake pedal is pressed, the engine stops, causing the planetary gears to stop rotating around the sun. The deaccelerating wheels then spin the ring gear, turning the motor into a generator. The electrical power generated in the motor, routed via the power control unit, is then stored in the battery, demonstrating the Ashwa HEV's ingenious efficiency. Reverse. During reverse, the engine is turned off to save fuel and lower emissions. As a result, the ring gear is rotated only by the motor. Power control unit. Essentially an onboard computer, it assesses and assists in the distribution of power to the motor and also in recharging the battery. It also monitors the performance of various components of the car, behaving like a data acquisition system, and relays the information to the team. ECVT. Managed by the power control unit, it is the onboard transmission mechanism that allows the engine and the drive motor to operate at their most efficient levels for maximum performance without compromising on efficiency. At startup and low speeds, under normal driving conditions, the power control unit has the engine off and the power is handled primarily by the front electric drive motor. At higher speeds, the hybrid system automatically initiates the engine to take over the bulk of the power production to be supplied to the rear wheels. The ECVT assists in seamlessly transferring this output to the wheels. Drive-by-wire. The mechanical linkages between the controls of a car and the devices that actually do the work are removed. Instead of operating the devices directly, the controls would send commands to a central computer, which would instruct the car what to do. The advantage of this is that the computer is able to make the steering, suspension, and brakes work together to give the car better handling, especially in bad road conditions, to give better fuel consumption, and to react to emergencies faster than a human driver could. It also involves processing of information of numerous onboard monitoring